Yeah, just
All right, so test was yesterday. These are the results. You can find your grade on PowerSchool, and the corrections assignment is posted due Monday. So
We have corrections for physics.
for some of you,
Yeah, me too.
it might be
Oh
good
my
to do
God.
the corrections.
71.
Okay? Any questions on the test?
No, pretty good.
All right, so we're starting a new little unit, and it's definitely review from stuff we did last year. It's a trigonometry thing. Okay, so the first thing I just want to talk about is just radians. Now, another thing, this is all review, so the fact that you're doing it again for the second year in a row must mean it's important, right? This is something that if you take calculus, which that's the purpose of this class, is to prepare you for calculus. If you take calculus, you need to know this stuff really well. So that's why we're doing it again, not to bore you or whatever. Some of you might be bored, and some of you might be like, oh, so I've never really figured out how to do that. Now I know, or whatever. So it's an important thing. That's why we're covering it twice. But anyway, today we're just going to talk about radians and degrees. So this is probably the third time you've seen this, because we definitely talked about it in geometry as well for a second. Hello? Yo. Yeah, she just walked in. All right, thanks. All right, bye.
How does it do that?
It was Hair Lake. He's like, Anna is on her way. She wanted to learn extra Deutsch today. Weird thing to say. All right. So radians and degrees. So remember, radians it's just another unit of measurement for angles, right? So both units of measurement for angles. So it's like kilograms versus pounds. So two different measurements for mass, right? Or Celsius and Fahrenheit, two different measurements for temperature, or whatever, right? Lots of different things have different units of measurement. This is one of those things, okay? So the first thing then is like, what exactly is a radian? Like, how did it come to be? So 1 radian, this is the definition of a radian. 1 radian is the measure of an angle which, if drawn as a central angle in a circle, drawn as a central angle of a circle, intersects an arc, intersects an arc whose length is equal to the circle's radius. Okay, that's a lot of words, but it's the measure of an angle which, if you draw it as a central angle of the circle, remember that's just an angle whose vertex is right at the center of the circle. It intersects an arc whose length of the arc is equal to the circle's radius. So like, for example, if I had a circle like this, and I wanted to draw an angle of 1 radian, suppose the circle's radius was 5 feet. Okay, 1 radian then, this is 1 radian, then it would intersect an arc whose length is 5 feet. If I were to straighten it out and measure it with a ruler, the length of that arc would be 5 feet. Does that make sense? So, I mean, you could just think about this intuitively. Do you think a radian is less than or greater than 60 degrees? What do you think?
Say that again.
Do you think one radian, just based on this definition, do you think one radian is less than or greater than 60 degrees? Less than, right? Because think about if I had an equilateral triangle whose side length was 5. Right? If I have an equilateral triangle whose side length is 5 feet, whoops, 5 feet. I did it again. 5 feet. Go away. Right? That's kind of what I have here. Right? It's this kind of an equilateral triangle, except I took one side and I bent it. If I take this side and I bend it so that it ends up being curved, but I don't change its length at all, this angle would have to get a little smaller, right? Right now the angle is 60, but if I bend that side so it bows out a little bit, then it would have to be less than 60. So that's, you could think of a radian as a little less than 60 degrees. Okay? So now that we have this definition, we can come up with some type of conversion factor between the two. Like for example, if I know that like 2.2 pounds is equal to 1 kilogram, right? 2.2 pounds is equal to 1 kilogram. And I want to find out how much I weigh in kilograms. I could do this. I could just set up a little proportion, right? I could say like pounds is to kilograms as pounds is to kilograms, right? So I could say, well, 2.2 pounds is to 1 kilogram as whatever, like 195 is to X. And then I could just cross multiply this. I could say 2.2X equals 195, and X is equal to 195 divided by 2. So I can use a calculator. 195 divided by 2.2. 88.6 kilograms, right? But the key was knowing this little conversion right here, right? Like if I know that 1 inch is like 2.54 centimeters or whatever, I can do the same thing to figure out how many inches are in so many centimeters, or how many centimeters are in so many inches, right? I could have done the same thing here to convert from kilograms to pounds, right? Here I converted from pounds to kilograms. Is somebody at the door? What's that?
Can I borrow a crack?
Sure. For how long?
Oh, probably like an hour.
Oh yeah, sure. Here you go. So I could have switched from kilograms to pounds just as easily. The variable would just be on top, right? Instead of on the bottom. So if we can figure out how many radians there are in a degree, or how many degrees there are in a radian, or some type of conversion, then we could do the same thing between degrees and radians. Does everyone agree? Okay, so the way we can figure this out is just to use circumference. Like if I know that the total, that's a good circle. If I knew that the total length of all the arcs in this circle is equal to the circumference, right? I could just divide by whatever the radius is to determine the number of radians there are, right? So I could just take, let's see. Okay, so the number of radians in a circle is really just equal to the circumference of the circle divided by the radius. Do you agree? Like if I drew this out, like say this was 5 again. 1 radian would be an arc of 5. A second radian would be another arc of 5. The third radian would be an arc of 5. The fourth radian would be an arc of 5. So basically, if I were to just keep dividing this out, 5, and 5. And figure out how many times does 5 go into that radius. That's going to give me, or how many times does the radius go into 5? That would give me the number of radians that there are. This is 1 radian, 1 radian, 1 radian, 1, and a little, right? So this formula should give me the number of radians in a complete circle. But I know what this formula is. This is 2 pi r divided by r, which is 2 pi. So the number of radians in a complete circle is 2 pi. 6.28, right? 3.14 times 2. This is about 6.28. Well, if there's 2 pi radians in a circle, that means there's pi radians in half a circle, right? So if I know that there's 2 pi radians, and that's the same number of angles, or the same angle as 360 degrees, then I know that pi radians must be equal to 180 degrees. Now, I'm not saying pi equals 180. Don't get confused by that. Pi is still pi, 3.14. That would be like up here, you thinking that I'm really saying 2.2 equals 1. I'm not saying 2.2 equals 1. Those two numbers are definitely different numbers. But 2.2 pounds is equal to 1 kilogram. That's true. Same thing here. Pi does not equal 180. Pi radians equals 180 degrees. That's the conversion. So if I wanted to set up a proportion to change from one thing to another, like suppose I wanted to change from 50 degrees into radians. So change 50 degrees into radians. All I'd have to do is just set up a proportion. I could say degrees is to radians, that's degrees is to radians. Do a proportion like that. I know that there's 180 degrees in pi radians, and I want to know how many radians there are in 50 degrees. So this is going to be 50 degrees over x radians. Now, it would have made no difference if instead of doing 180 over pi, I did 360 over 2 pi. It's the same, right? Stuff's going to like divide out. So I just changed it to pi and 180 just to make the arithmetic a little simpler, less stuff to cancel. But it wouldn't have made a difference. And now how do I solve for x? Cross multiply, divide, whatever, right? So if I cross multiply, I get 180x equals 50 pi. So x is equal to 50 pi divided by 180, which I can simplify a little. I get 5 pi over 18. And that's the simplified number of radians in 50 degrees. Or I could do it the other way. I could say, suppose they asked us to change negative 5 pi over 4 radians to degrees. Same process. I have 180 over pi equals degrees over radians, x over negative 5 pi over 4. And I could do the same thing, just cross multiply. I get pi x equals 180, I'm going to write it, times negative 5 pi over 4, which if you do the numbers here, if you take 180 divided by 4, that's 45, times 5 is 225, so this is actually 225 pi, negative 225 pi. And then just divide by pi. So x is equal to negative 225 degrees. Now there's a little shortcut. This way works every time, no problem. But there is a little bit of a shortcut. And the shortcut is, if you just think about what the proportion is that we're doing. It's 180 over pi equals degrees over radians. That's the formula that we're doing, right? If we know the number of degrees, we plug it in there and solve for r. If we know the number of radians, we plug it in there and solve for d, right? So this works every time, no problem. You can do it this way. It works great. But the shortcut is, if you just solve this like by cross multiplying now, or like let's just say you just multiply by r, you get d equals 180 pi times r. Well, that's a shortcut. I can take the number of radians and multiply it by 180 over pi. Or another way of writing this as an equivalent equation would be pi over 180 times d equals r, right? All I did now is I took this equation and multiplied by the reciprocal of this fraction on both sides to solve for r. These are the shortcuts. Like, just think about the two problems that I just did. The first problem was we had 50 degrees. If I take pi over 180 and I multiply it times 50 degrees, I get 5 pi over 18, which is the same answer I got before with a little bit less writing. And the other example I gave was negative 5 pi over 4. If I take 180 over pi times negative 5 pi over 4, you can see right away the pi cancels, and I just have to evaluate the numbers situation here. It's negative 225. I get the same answer with considerably less writing than I did up here. Look at all the writing I did for that question up there, and all the writing I did down here. I'm saving myself a little bit of work. So the shortcuts, are, if you're going from degrees to radians, you're going to multiply by pi over 180. And if you're going from radians to degrees, you're going to multiply by 180 over pi. Now, you should never get this wrong this year, because you have an open notebook. So never get this wrong this year. But try and practice it without looking at it so that you memorize it, because you do need to memorize it for the future. You can take any math class whatsoever. You need to know this stuff. So take advantage of the open notebook all you want, but make sure that you're learning something that's going to help you as well. Okay? So that's basically it for the homework. They're going to ask you to switch from radians to degrees or from degrees to radians. Now, I just wanted, before we're done, I'm not quite done, I just want to talk about just recognizing certain common angles when they're in radians, because my brain works better in degrees, I think better in degrees. So when I look at something that's in radians, I automatically kind of want to change it to degrees. And if you have like a short way of like doing that quickly, you'll save yourself a lot of time in the long run. So here's the way that I kind of remember it. I just remember that if you have like 30-degree reference angles, now remember, reference angles are angles that the acute angle that goes to the x-axis is 30 degrees. So think about what that is. That's like 30 over here. It's 150 over here. This is 30, 150, 210. That's a 30-degree reference angle, or 330. Those are 30-degree reference angles. 30-degree reference angles always have the same structure when they're in radians. It's like something pi over 6 rather. It's something pi over 6. So like this is pi over 6. This is 5 pi over 6. This is 7 pi over 6. This is 11 pi over 6. It's something over 6. So if you see an angle that's in radians and its denominator is a 6, then it's a 30-degree reference angle somewhere. So it helps you come up with the answer a little quicker. If it's a 45-degree reference angle, then it's something pi over 4. And if it's a 60-degree reference angle, then it's something pi over 3. Okay? So that's kind of just a short way of just coming up with answers really quickly. So if the question was pi over 4, for example, which we had an example like that, I know it's a 45-degree reference angle. I know it's a little more than 4 pi over 4, which would be 180, right? It's a little more than that, so it has to be the 225 is the answer. You follow my train of thought there? So if it was something like 4 pi over 3, I know it's a 60-degree reference angle, but I know that it's a little more than 3 pi over 3, which would be 180. So 60 degrees past 180 would be 240. This has to be 240. Now, if that's not helpful to you and that's confusing to you, either think about it and make it not confusing to yourself, or just ignore what I said. You don't really have to be able to do this, but it'll help you in the long run if you can identify common radian angles by a glance instead of having to do all the math behind it. You understand what I mean? All right. So that's it for today. The homework is on delta math, and it's just called radians and degrees. That's it. I will. Let me just stop recording real quick. Definition of radian. Right there.
It's my